Hi everyone, this is Shravan from Eclipse Platform Project. I am Eclipse Platform Project co-lead and also commentator on Eclipse Equinox. I primarily handle Eclipse launcher issues as well as platform Releng issues and uh, SWT issues. Today I'm going to talk about Releng part of it. We migrated our build system from a dedicated Jenkins instance to JIRO. This is what I'm going to talk about. Okay, here are the items I'm going to talk about. I will give you a very brief overview of release engineering at Platform Project, and I will give you overview of old Jenkins infrastructure and why we need JIRO and what are the features which we get, and along with that, what are some of the features which we had were removed for the security issues and some resource encroachment issues. So, and finally, how we did migration and what are the challenges we faced. Now, first, at Eclipse platform, we use a couple of tools for release engineering. The first one is continuous Jenkins, and we have 5 different instances, one for release management and 4 for Gerrit integration. Okay, for the release management, we have one specific Jenkins instance called Releng instance. We use builds, we use daily builds here using the latest source code, and also we use the same Jenkins instance for promotion after testing and verification. And this also does a lot of housekeeping tasks as well. Then we have 4 different Jenkins instances just for Gerrit verification jobs. Platform, okay, for a small information, platform uses about 25 Git repositories. So we need to have multiple Gerrit verification jobs to verify the incoming patches. How Gerrit works is here is a typical workflow. User fixes a bug and submits code contribution to Gerrit, and Gerrit triggers a validation job on Jenkins. Because we have 25 of them, one Jenkins instance is not sufficient for us actually. What Jenkins does is it compiles the code and runs the unit tests. We have some Git repositories which are still not configured for unit tests. Compilation will give you +1 or -1 based on compilation result, and we'll get a verification +1 or -1 based on compilation of code and unit test results. Then another user reviews the patch and gives +2 and submits a patch. While submitting, it gets merged to the corresponding Git repository. Now, here is a world infrastructure. We have 4 different Jenkins instances for Gerrit validation job. These are PDE, JDT, Platform, and Equinox. All these have one Jenkins instance and multiple executors on the master node itself. We used to run multiple jobs on the master node. Master node. And next one is a Releng Jenkins instance. This is used for build management. For this one, we use storage from build.eclipse.org and download.eclipse.org via NFS, and we have dedicated executors and machines for native builds, test runs, etc. Here job used to take close to 3 hours. Build job takes close to 3 hours. So here, if you see the native builds are USWT native code as well as launcher native code builds. These machines are used only 15 minutes per week. Here, we used to waste a lot of resources here. Similarly, test runs, during the test run, it takes about 8 hours per day. That's a maximum limit. There also, we are using only 1/3 of the time. At that time also, we don't need heavy machinery, actually, heavy usage. We don't need big processors, etc. or RAM. So we are actually not using resources properly. Now, because of these reasons, and also because of these reasons, we have to move to JIRO. What is JIRO? JIRO stands for Jenkins instance running on Openshift. As you know, Openshift is built on top of Kubernetes, providing container-based infrastructure. Whenever a Jenkins job is run, a new Kubernetes pod gets deployed and a job is run inside that. So you have control over how much resources it is going to use, what kind of Docker image we can run inside the container, etc. You will have the control over it. Because of because it is a container, if base node has failed or something happened like that, you can easily move over to a different node. Just you need to move the pod to a different node. At the same time, because you have control over resource usages, you can have much more Jenkins instances hosted in this OpenShift cluster, and also nimbleness. You will achieve much more speed also. So here are the requirements from the foundation. As you see, this week itself, we have seen multiple new projects announced in the last year. For these new projects, you need to have new Jenkins instances for their build needs. So foundation has to set up new Jenkins instances, but infrastructure is pretty limited here. So we need to utilize available hardware better. It's better to move to a containerized environment. And also another problem we have is, for example, in our example itself, platform Releng, during the milestone week, you will have a lot more builds running. So it uses heavy resources. And in the earlier infrastructure, Jenkins instances are hosted on big servers, and they are shared. Each server has about many Jenkins instances running on them. Because of heavy usage of one particular project, other projects which are sharing that particular server are not getting resources there. So this also we have to control it. And with OpenShift, you can definitely limit how much resources you can have. So that is what that requirement also can be achieved with this. Similarly, similarly, for the build or test requirements, there may be some specific tools which needs to be installed on the build servers as well as test servers. If you provide a Docker image support in a container, a foundation can move the management of the machines to project teams. So this is also one of the requirement. So now let's see how what are the new features we got with JIRO. So with JIRO, we can run Jenkins jobs in a container, and this container can use a specific Docker image, and that Docker image can be created by project teams. And you can project teams can specify limits on resources per a job, so that it doesn't encroach on another job instance. But this requires some converting all our jobs to pipeline jobs. Most of the people are not using pipeline jobs. They normally use freestyle jobs, and this will be a huge task. So thanks to Foundation guys, they created a migration pod template so that we can use it in freestyle job. And if you use this migration pod template, this will mimic your earlier job execution. Okay. Now this also required some. This also came with some restrictions. First one, when you are moving to containerized environment, Java 7 and above is optimized for containerized environment. So our bundle execution, required bundle execution environment has to be moved to Java 7 and above. This is not a problem for Eclipse because Eclipse was not supporting Java 7 and below when we started this job. So we moved, but some of the bundles still running on Java 1.4 or Java 5, and we did had Java 6 and 7, Java 6 bundle execution environments also used in Eclipse projects. Second problem is in the earlier instance, we used to have workspace always available when the job is completed. For example, in case of test runs, we could go into the workspace and see if there are any problems or if there are any issues in the workspace itself. But since it is running in a containerized environment, workspace is created on the container. So once the job is completed, you will not have access to workspace. This is not exactly a problem, but this is inconvenience which we will get when migrating to JIRO. To overcome this, you can use archive feature in the Jenkins jobs. The second set of restrictions is the resource restrictions. These resource restrictions came up in JIRO. By default, each Jenkins instance comes with two executors with 2 CPU and 4 GB of RAM. 2 executors means you can run 2 jobs simultaneously on that particular instance. If you use pipeline jobs, you can split the resources and run more jobs, but for all practical purposes, it is only 2 jobs you can run simultaneously at any instance. Now, for platform and for platform projects, that is not sufficient. So we need more executors. So what Foundation has done is they assigned something called resource packs to Eclipse corporate members, strategic and solution members, and they have there are a set of resource packs which are assigned to each of the corporate members, and they can sponsor resource pack to a particular Jenkins instance, and each resource pack can provide 2 more executors. So if you need 4 simultaneous jobs to run, you need to have default executors, 2 executors, and 2 more sponsored by a corporate member. This is how you need to we had to overcome it. Then with JIRO, we are not completely going away with the dedicated machines like Windows and Mac are not yet on clusters. So we need to have a dedicated connectivity to that. So by default, these are not provided by Foundation. You can either create your own machine and attach it to your Jenkins instance so that you can have more executors, or any corporate member can sponsor a dedicated agent. That dedicated agent will be attached to this particular server. So a particular Jenkins instance. In case of platform, we test on Mac, Windows, PPCLE, ARM64. So what we did is we got two dedicated agents sponsored by IBM and Red Hat for Mac and Windows. Then for PPCLE and ARM64, we got donations from for ARM. ARM kindly donated one machine, and it is attached to a platform and Releng Jenkins instance. And for PPCLE, Oregon University and University in Sao Paulo, Brazil have donated 3 machines there. So let me start with what are the steps we have taken for migration of Equinox, PD, JDT, and Jenkins instance. These 4 instances are used for Gerrit validation jobs. Here we have the first one to migrate is Equinox instance. The first thing we had to do is we used migration part template and migrated all the jobs. And it turned out a couple of jobs failed. And we had to upgrade the project to Java 8. With that, we got Equinox instance migrated. The second one is PD instance. PD's instance is the smoothest one. Actually, there are no problems, to be frank. Yes, we just migrated all the jobs using migration part template. There are no problems here. Next one we targeted was JDT instance. Here we had a problem. In JDT instance, we have JDT UI component. JDT UI component ships JUnit bundles, but these JUnit bundles require Java 1.4. So it took some time to upgrade these projects to Java 8, and then we used a migration part template again for this one and moved them. Now, another problem we had was because JDT jobs take huge time. They take typically 3 hours, and with more than 150,000 tests to run, we have a queue of Gerrit patches lying around. So if you have to, when we had only two executors, we are not able to cope up servicing all the Gerrit validation jobs. So we had to increase executors here with sponsorship from IBM. Then we have platform instance. Then we started with platform instance. In case of platform instance, most of the jobs are already on Java 8, so we didn't have to do anything for the code migration. Then for the platform instance, we have more number of users. So during the milestone week, we can see a lot of jobs running at once. So we had to get the executors increased to 8 with a sponsorship from IBM, Red Hat, and Mozilla.com. Other problem Except for SWT job, all of the jobs we used migration template and moved them. For the SWT job, SWT requires native build. SWT has a native build component, so native build has to be done. So we created our own Docker image, and with custom pipeline, we are able to get the SWT job also migrated. Okay, this is the last Releng Jenkins instance which we moved. This was used for This is used for build management of Eclipse platform projects. That includes Equinox also. The first problem we had was our build requires more than 6 GB of RAM. But when we use freestyle job, we'll not get 6 GB of RAM. So we have to come up with our custom pipeline. So we configured our build job to use about 8 GB of RAM. That means 2 executors will be used when our build job is run. Since we are using custom pipeline, we split. We actually rewrote our build scripts and split everything into different stages. And then during the build stage, we have to build SWT native libraries also. Because of that, the default number of executors is not sufficient. Default number of executors is 2, and those resources are not sufficient to run even one build job, one regular build job. So we have to run SWT build jobs as well, SWT native build jobs as well. So because of that, SWT build job requires 3 more executors. And because of that, we have to increase, and we have tests also running in the same one. So because of that, we had to increase executors to 8. Then this also gave us an idea. Why don't we run smoke tests on different different combinations of OS and Java versions? So we implemented that as well. We run smoke tests on different Linux variants with Java versions, Java 11 and Java 15. On Linux also, we run on Ubuntu 18, 20, CentOS 7, CentOS 8, CentOS 8 on PBCLE and Raspberry Pi OS. We actually run these combinations there. This is one of the advantage we got when we moved to JIRO. To run this, we created our own Docker images, and we use those Docker images. Now, our official test runs normally run on CentOS. If required, we can easily migrate to a different OS as and when required. As long as there is a Docker image, we can use it and straight away switch to that. And for the other housekeeping jobs and build promotion jobs, we used migration path template here. And for some of the jobs, we use default template as well, where you don't need much of resources. Okay, for going forward, this is what we have done over the last week. Going forward, if you look at these resource pack usages, we are heavily using resource pack. Each strategic member gets 10 resource packs, and IBM exhausted about 5 resource packs only on the platform project, and 2 dedicated agents, and IBM exhausted their 2 dedicated agents on the platform project itself. So one way to do it is we have to we have to architect our Gerrit validation jobs and other jobs to use less number of resources. For that, we have to migrate our jobs to pipeline jobs. We definitely welcome contributions from the community in this area. This is what I wanted to talk about, the challenges we had. Majority of challenge we had was writing our own custom pipelines, developing Docker images, and convincing corporate members to part with their resource specs. Okay, here are some references. Okay, any questions? Okay, please go ahead and read the talk. Thank you for your time. Thank you all for your time.